In lesson 6.2, we're going to be discussing comparing and ordering fractions, decimals, and percents. When comparing and ordering fractions, decimals, and percents, write the numbers as either all fractions, all decimals, or all percents. They have to be in the same format in order to be able to compare or order them correctly. It is helpful to write them as either decimals or percents because they are easier to compare. When we use fractions, they have to have the same denominator in order to be able to compare them. So here, if we look at which is greater, 25% or 7/25, we can change 7/25 to a percent. Remember that percents are always out of 100. We know that 25 times 4 is 100 and 7 times 4 is 28. So 28 out of 100 would be 28%. We can then see that 25% is less than 28%. So 7/25 would be the greater number. Go ahead and try number 2 on your own. As you looked at number 2, you could have either changed it to a decimal or a percent. So I'm going to change these both to decimals. So remember, to change a percent to a decimal, we move the decimal point 2 times to the left. So we're comparing 0.49 or 49 hundredths and 0.94 or 94 hundredths. So 94% would be the larger number. On number 3, it says you make 75% of your shots, your sister makes 13/20ths of her shots, and your friend makes 7/10ths or 0.7 of his shots. Who made the most? So again, we either need to convert these all to decimals or all to percents. So let's go ahead and convert these to percents. So again, we know that percents are always out of 100. 20 times 5 makes 100. 13 times 5 makes 65. 65 out of 100 is 65%. Now go ahead and change 0.7 to a percent. As you change 0.7 or 7/10ths to a percent, you move the decimal 2 places to the right and added that 0 for a placeholder. So we now are comparing you with 75%, sister with 65%, or your friend with 70%. Who made the most shots? Well, the largest percentage is you. So you made the most shots. The portion of the U.S. population that lives in Texas is 2/25. The portion that lives in Illinois is 0.042 or 42 thousandths. Reorder the states in example 3, including Texas and Illinois. So we can see that we have Texas and Illinois, Washington, Michigan, New York, Ohio, and California. So I'm going to go ahead and write the state names out, or the abbreviations is fine too. Okay, now we should have 1, 2, 3, 4, 5, 6, 7 states listed. 1, 2, 3, 4, 5, 6, 7. Let's go ahead and then write down the fraction, decimal, or percent we were given for each one. So 2/25 for Texas, 0.042 for Illinois, 1/50th for Washington, 0.03 for Michigan, 6% for New York, 1/25th for Ohio, and 0.12 or 12 hundredths for California. We now either need to convert all of these to decimals or percents to be able to compare them. So I'm going to go ahead and change them all to decimals. So we can start by getting a unit fraction, so 10, 100, 1,000 on the denominator. So 25 times 4 is 100, 2 times 4 is 8. So I have 8 hundredths, which can be written as 0.08. 1/50th to get to hundredths, we know we times by 2. 1 times 2 is 2. 2 hundredths is written as 0.02. Now go ahead and try to change the last couple to decimals. All right, you'll see here that I finished these up. So 1/25 is 4 hundredths or 0.04. 6%, we take that decimal point and move it 2 times to the left. So 0.06. Now we're going to order these from least to greatest. So the smallest one would be Washington at 0.02. Then we can keep going from there. So after that, we have Michigan with 0.03. And I like to kind of mark them off or check mark them as I go, so I know that I don't use them twice and I don't forget any. Then after 0.03, we have 0.04 for Ohio. Whoa. After 0.04, I can see that I have 0.08, 0.042, 0.06, and 0.12. So next would be 0.042. So this is like 4 hundredths or 40 thousandths, and this is like 42 thousandths. So next would be Illinois. Then we have New York. Texas. And our largest population is in California. So see here how we had to convert them all to the same type of number, either a decimal, a percent, or a fraction with common denominators in order to compare them. In number 5, it says the table shows the results of 8 teams competing in a scavenger hunt. Which team collected the most items? Which team collected the fewest items? So again, we need to convert all of these to the same format. So I would choose in this problem to convert to decimals. So when I do that, I know that 3/4 can get to 100 easily. 4 times 25 is 100. 3 times 25 is 75. So 75 over 100 is 0.75. So I would just kind of write this under here so I can keep going. I already have a decimal. Change the percent to a decimal. We know we can move 2 times to the left. Already have a decimal. Now, when we get to these fractions that we can't convert these evenly or easily into a 10, 100,000 into those unit fractions to help us with our decimal place value, we can take the top number and divide it by the bottom number. So what I mean by that is we can use that long division. So 29 divided by 40. So go ahead and divide this now. As I divide, I know that 40 can't go into 2 or 29. It can go into 297 times. 7 times 40 is 280. Now, 40 can go into 100 2 times. 40 times 2 is 80. When we subtract, we can find that 40 can go into 200 5 times. 40 times 5 is 200. I can bring that decimal point straight up. So my decimal here is 0.725. Now, after you convert all of these to the same type of number, either those decimals, percents, or fractions with common denominators, you can then choose which one is the greatest and which one is the least. Go ahead and finish the conversions now. Now that I've changed all of these to decimals, I can then pick out the least and the greatest. So as I do that, I can see that my numbers all range in the 0.7 to 0.8 something, decimal range. So we're going to start by comparing the 0.7s. So any of them that have 0.7, we're going to compare. So when we do that, these are all less than any of them that start with 0.8. And we're going to look at the next numbers. So here's a 5, a 7, a 2, a 6, and 8. We need the least. So of those next digits, the 2 is the least. So that corresponds with number 5, 29/40. So when it says which team collected the most items or which team collected the fewest is team 5. It's asking us which team, so we need to make sure we're answering what it's asking. So team 5. Now, when we're looking at the greatest, we know that our numbers with 0.8 are our larger numbers. So here we can compare the next digit. Well, if there's no digit, it's a 0, a 2, or a 1. The largest of those would be the 2. So team 4 collected the greatest amount of items. On number 6, it says order the following numbers from least to greatest. First, decide on a strategy for ordering the numbers. Will you write them all as fractions, decimals, or percents? Use your strategy and a number line to order the numbers from least to greatest. Make sure you label the number line appropriately. Now, with this being said, you need to do all of your conversions first to then decide how to number your number line. I'm going to give you a few minutes to go ahead and complete this, and then you can come back here to check to see if your answers are correct. Again, it doesn't matter if you convert to percents or decimals, or if you really want to do fractions, you can, but they have to have common denominators. A lot of times I'll look to see which one would have the least amount of conversions. So for instance, here I know I have 3% and 3 decimals. So it doesn't really matter because we're going to be doing the same amount of conversions either way. You can now see that I've completed all my conversions and I've kind of written them here above each number. The next thing I would recommend you doing is writing these in order from least to greatest. As we do that, we want to go back to the original format because when we number our number line, it's going to need to use the original formatted number for our answer. Now, as you can see here, I decided that counting by tenths was the most appropriate choice for my number line. It's going to have a lot of data in one section, in one small section, but we have to have all the way up to the 8/10 and 9/10 range for some of my answers. So this is how I numbered my number line. Now I'm going to go back through here and write my original formatted numbers in where they belong. So 0.07, that's going to be between 0 and 0.1. So that's 7/100. So that's 7/10 of the way to 0.1. So I'm going to say it's approximately right here. Now I have to write that in my original format. So that's 7%. Now 11% or 0.11 is going to be slightly above 0.1. So 11%. Now go ahead and finish these out here. You can now see that I've placed the rest of my numbers on the number line. Again, using that original format from the problems, I've kind of drawn my marks and I've adjusted the length of them so I could fit all my numbers in accordingly, even use the top of the number line if we needed to.